Okay, so number 7 is a little tricky, and it has to deal with a quadratic and a square root. Okay, so one of the things, before I even start, whenever I'm dealing with a quadratic or the square root symbol, what I want to realize is that the inverse of a quadratic is a square root, and the inverse of a square root is a quadratic. So we do have that option here. We have both a quadratic and a square root. So it's possible that these are inverses. So we have to go ahead and do our composite and see if they work out. If you look at number 8, where we have a square here, but there's no square root, this is a linear. Okay, well, there's no way I can take the inverse of a square root, an inverse of a square, and get a linear function. So this is not going to be an inverse. I already know without doing work. Same with the linear. If I take the inverse of a linear, I get another linear function, not a square, not a quadratic function. So right there off the get-go, on number 8 is not an inverse. Okay. However, on 7, it's possible. Okay, I got a quadratic and I got a square root, so it can be. So we got to do further testing. So again, I'm going to put g of x into f of x. So f of g of x here. Again, build your shell. So I'm going to take all of this here, and it's going to go into this x right here. All right, so I got a negative, put parentheses for my x, it's going to be squared, and then a minus 1. Okay, and then in this parentheses, I'm going to put my g of x function, plus or minus square root negative x minus 1. All right, so the square root and the square cancel each other out, and what I get is a negative plus or minus square root negative x minus 1 minus a 1. Oh, sorry, no square root. There we go. Negative x minus 1 times 1. The square root canceled with the square. Okay, so then I'm going to distribute this negative in here, which is going to give me x plus 1 minus 1. Then I know that these plus 1s and minus 1s cancel, and I get an x by itself, which means they are inverses.